Welcome back, and I've decided to redo this video a little bit. This is another LabVIEW video, and it's about a two microphone, well, what I call an adaptive beamformer, and I suppose it is that. And it's entirely written in LabVIEW. There's no real, strictly speaking, real-time implementation on Rios and so on. So it's written on a PC, and so it's not strictly speaking real time, but it still works okay. I suppose it's close to real time. And what it is I've got two microphones over here, and of course this can be extended to more than two. And I've got a preamplifier here, and that goes straight into the sound card. The microphones are placed about 12 inches or so apart, deliberately. And the idea here is that to cancel any noise that's outside of a predefined zone or a zone of activity. And the zone of activity is going to be sort of in this direction here. And actually it's behind as well. With two microphones you can't help that. So what I've got is a voice activity detector which works in a zone in here somewhere. And if you go to the right of the zone or the left of the zone over here, then it'll treat anything, any noise that's there, any signal there as noise. So anything in this area here it will treat as signal and desired. There's already a small noise in the background which is due to the air conditioning. If we look at it running, you'll see that there are three huge LEDs, or lights here, left of zone, valid speech, and right of zone. So if I turn it on, at the moment I'm speaking to the right of the zone, and you see it's picking up there the fact I'm on the right. Let's move into the middle, and I'm speaking in the middle of the zone now, and you can see that the light in the middle where it says valid speech is coming on. Now we've got moving to the left of the zone, and you might be able to see the light on the left is now moving. These graphs, the top one is just the speech, the enhanced speech, and below is the spectrum. I'll explain a bit more about that in a minute. It can also more or less work out what the bearing is as well, what angle that you're at, because the way this works is by finding the time delay difference between the two microphones. So as I'm speaking in the middle now, you can see it's there'll be a very small delay, close to zero, between the two microphones. And how it works that out is with fast Fourier transforms and cross correlation. The cross correlation, ordinary cross correlation, only works very well when you've got white noise, unfortunately. That's not that well known, but white noise works brilliantly for cross correlation. But if you've got speech signals, then you get a situation where when you work out the delay, it's a bit more ambiguous what the actual delay is if it's coloured signals. And so there are methods going back to the 1970s called the generalised cross correlation, and that method uses coherence, and I'm using a particular method called the Hannon-Thompson method, although there are other methods like the Scott method and so on. There's about 4 or 5. This is the one I feel is give me the best results so far. So if I work out a delay that's greater than a certain amount, clearly that means I'm out here somewhere on the right or the left hand side, and I can tell whether it's on the right or the left hand side by the sign that I get, whether it's positive or negative. So that's that. So let's have a look at the program working again. And I've got a button which will turn the canceller on and off. And just to begin with, rather than showing it with speech, I'm just going to do it with the ambient noise. I'm going to look at the spectrum as the noise without the canceller on. I'm going to average it, and then I'm going to put the canceller on. So for this I'm going to not speak, otherwise it'll pick up my speech. But The button for the canceller is here, and I can average the spectrum here. So I'm going to start with the with this now. So I'm going to talk in front of the microphones to activate the canceller. It sort of does a steering, automatic steering. Unfortunately, it picked up my voice there, so I'll do it again. I turned it off, and you can see that the noise level has gone down right across the spectrum, almost up to 10 kilohertz. It's dropped by about 10 dB. Quite impressive. You can see this little meter here. You'll see it also working here. So that's right across the spectrum. That's almost the sort of background or white noise levels all gone down. I'll turn this off again, clear it, and turn the canceller on. Now watch the needle here as I'm speaking. I'm going to stop speaking and then I'm going to switch it on, and you should see the noise level going down. And it can go down as much as 10 dB. Now, how does it cancel noise? Well, what it does is it's got two least mean squares algorithms in it. This is a method in the literature that's quite old, really, and in fact the original video I made of this, it didn't come out too well. It was done by an old video recorder, old camcorder, so this hopefully we'll be able to see a bit better on this. But it uses two least mean squares algorithms, and you can probably see down here the steering weights here changing. The filter weights aren't changing because I haven't got the canceller on now. Filter weights change and the steering weights don't, depending on where I'm speaking. So how to demonstrate such a thing, that's the problem. So what's supposed to happen is when I speak in the middle here, then the speech should come through and any background noise should disappear. There's not a lot of background noise at the moment, but I can show you it attenuating the speech, because the speech will also act as noise. As I go over to the right hand side of the zone, you can see that the speech level's gone down now. It's very difficult to let you hear this being recorded, because the microphone picks up my original speech, and the speech coming out of the headphones gets sort of swamped by that. But I can show you the magnitudes there. You can see it's much smaller as that's getting in the zone again. Now let's move to the left hand side of the zone, and the left hand side it's also attenuating. You can see the speech is nothing like as big. It should be going down about at least 6 to 10 dBs. Back into the middle and the active zone, and the speech is back up at its maximum again. Of course I can put the headphones on to the microphone, but I don't think you hear much, but that's it in the middle of the zone now, and if you can hear sort of two speech signals, that's myself and the cancelled one, the original one. Sorry, it's not cancelled because I'm in the zone at the moment, so there should be two. As I move to the right, you should only hear one, because the other one will be attenuated. So now you should only be hearing my original voice and not the second version. That should be very much cancelled. Go to the other side in the middle again, and you should hear two signals, my original and the enhanced one, which is being let through. Now as the speech becomes a noisy signal over here, you should probably just hear one signal. Let's see how that works. Thanks very much, and see you the next time. Bye bye.